Well, hello guys, welcome back to John's Workshop, and in this video we're going to be manufacturing a twin cylinder block for a model engine. This is for one of my viewers, and the guy's name is Martin Currie. He has recently got into the hobby, recently set himself a workshop up, recently started teaching himself CAD drafting and machining as well. So Martin was struggling with the manufacture of this particular component, so he's basically redesigned this engine to be 2 times its original scale. The engine's name is the Bog Standard, and it was originally designed by the late John Moore, and any of my viewers who are model engineers may recognise that name and know what that all means. I don't, unfortunately, but what Martin's done is taken the original designs, scaled it all up to twice original scale, and he's busy making and building that engine. Martin has shared his plans, I think, on Model Engineering Forum of what he's doing, so you may find information on there, but Martin has also agreed that he's more than happy for anybody to contact him if they would like a set of the plans or like to know any more about the engine. So I'll leave some details about Martin in the description. I nearly said comments then, in the description of this video. So what we're going to do in this video is manufacture the cylinder block, and unlike a normal model engine build on a YouTube channel, you're not going to see me make the entire engine and show it running, but you are going to see this video, which is largely going to be maybe hopefully interesting in terms of the way I'm going to attack this, because I have some restrictions in terms of my tooling that I want to use and which machines I need to deploy those on, and that will become obvious as we get into it. I think I've covered all the points on the board there. Yeah. So Martin has sent me a lump of material in to make this out of, and also sent me the plan or the drawing sheet that pertains to this particular item in the engine. So without any more babbling, the first job is we're going to get this in the saw and chop a lump off the end of it, because this bit of stock is a little bit too long. You don't need to watch that getting sawn off, so when you first see me again, we'll be at the milling machine starting to block this out, getting ready for the start of the manufacture. Okay, so as I demonstrated at the beginning, this machine struggles with anything that's interrupted cut, i.e. a face mill, a fly cutter, in its current configuration, and you'll have heard the noise. That's always been the case since I bought it. That's got nothing to do with the spindle exchange that we've done. I think the problem's further back, i.e. in the power source or the motor. So what I've done is set a fly cutter up. I've got an old Wimmet brazed carbide tool, turning tool in there, and when I roughed this out using the roughing cutter, the ripper cutter that you saw, that got the material off that I needed to get off in probably the quickest time I could on this machine, and I've left myself a few thou all over for a finish cut, and we're just using this fly cutter now to get a decent surface on all the surfaces, because this is going to be in a model steam engine it's going to be on show and it needs to look fairly reasonable. So I'll just show you a bit of that. So there we go, that's leaving me a cracking finish. So I'll carry on now with bringing this down to finished dimensions all over using this method. Okay, we've got our block all fly cut in the same method, making sure we've retained squareness. Cleanliness being a really big thing here to get a good dimensional accuracy. So a question some people might ask is, well, how accurate can you be on an import Chinese milling machine? Well, let's have a look. So our overall length, we're aiming for 110 millimeters. So we've got our micrometer here. Not doing a very good job of showing accuracy here, John, are you? Really? There we go, we've got a feel on there now. So we're 110.01. So we're within 10 microns or a hundredth of a millimeter that way. The other way we should be measuring 64 millimeters, so that's on this end of the drawing here, 64. So we'll just check that. So what I've been doing is checking parallelism as well, which is, yeah, it's pretty good all over. So about the same with 64.01. So again within 10 microns, and final dimension is down here, which is 36 millimeters. And again with 0.01 up, 3601. So that's all three dimensions within 10 microns of finished size. So happy with that. We can now move on. We're going to go back onto the mill now. We're going to set back up and we're going to start putting all of the other features into the block. Okay, we're set up ready for drilling all of our holes in the first side. We've got our drawing on a magnet on the front of the machine, and unfortunately the drawing is datumed all from one corner, therefore I've set my datums using an edge finder on that corner, and I'm now just going to work to the dimensions on the drawing. What I've done is, in with a Sharpie and a 6-inch rule, is just mark some dots roughly where the holes are going to be, just to avoid hopefully any silly mistakes when we get into the drilling. So I'll bring you back in a moment when we start putting the holes in. So there we go, 5 more to do like that with this is a lead tap, first tap, M6x1, and then what I'll do later on is drop down with a plug tap, because these are only 10mm deep. So I'll bring you back when we've done all this tapping. I'm doing nothing with these 2 centre holes yet, so I'll bring you back when we're doing the three holes round each side of the centre hole bore. Okay, what we've done is we've set up, so I've still got my original in my DRO 00 corner here. I've set up in my SDM function, which is the datum memory function. I've set up a datum around the centre of this hole and a datum around the centre of that hole. So my DRO now knows there's 3 separate datums on this one part, and around this first datum I've programmed in my pitch circle diameter to produce the 3 tapped holes that we need to put in here. So we'll just get on with that now. So there we go, that's got our first pattern of 3 holes done around our first central bore. I'm now going to do the same around the second one, not going to film that. And then the next job is I'm going to tip this whole block through 180 degrees, and I've pretty much got the exact same pattern of features to put on the underside, obviously minus the 2 bore centre holes, because I only need those on one face. So I won't film that because it's the same as what I've done, and then I'll bring you back when we're going to tip this thing on its end. We've got a pattern of holes to go in this side and the opposite end, so I'll bring you back when we're doing that. There we go, that's got our first side complete. 2 steam ports and 4 M4 holes tapped to depth. So I'm now going to flip this whole block 180 degrees, and I've got exactly the same pattern to do on the other end of the block, so I'll not film that. So there we go, that's our second side done. So that's all of the small holes complete now. What I will say is that that little M4 tap has worked incredibly hard. So that's done about 170 millimeters of thread in this job, which is near enough 7 inches. So that really has worked hard on this job, but no bother, we're all done. So next job, I'll join you at the lathe when we're setting up to put the 2 cylinder bores in. Okay, we're just getting set up on the lathe. So we've got our 4-jaw chuck in, and we've roughly eye-sighted one of the centre drill holes that is the centre of one of the cylinder bores up, and it is just roughly eye-sighted at the moment. And what I've been doing is checking with the DTI my squareness, and just with a bit of influence in, just using my sort of knocker, tapper. We've got this so that anywhere I look at this, I've got no movement at all on the DTI. And I know you probably can't see it because it'll be blown out. I'll show you that in a minute. So why am I doing it this way, you may all ask, and you'd be absolutely right to ask that. Why on earth didn't I just use my boring head on the mill when I had all of this set up on the mill doing the rest of the holes? And that's a very, very good question. So there's 2 or 3 reasons driving the answer to that. The first and main reason I've got is I've just changed my spindle over for the ISO 30 spindle. The splines on the back of that spindle are much shorter than they were on the Morse Taper 4 spindle that I originally had in, that came with the machine. And what's happening is, because of the drawbar that came with that, when the drawbar gets down to the top bearing, it stops because there's a fouling on the clamping nuts at the top of the drawbar. And I've got new drawbars that I need to make, and all of that hopefully will get addressed at that point. So what that all means is, currently on my mill I don't have enough quill travel to get right the way through this block. So to try and use my boring head would just be a nightmare, because I'd be having to try and unlock my head and move my head halfway down through the hole. These are cylinder bores for an engine, and that's just no good at all. So the only option I really had was the lathe at this point, until I fixed the mill, which that will come later on. That's one reason. The second reason is I want to really make both of these bores exactly identical, and if I'm using the boring head, there's always the chance that one's going to go slightly oversized or undersized because you've got to do loads of measuring. And what I do have is a 20mm reamer, which is in reasonable condition. The finished bores are 20mm, and I really want to use this reamer. Again, I could have just about maybe squeezed this into the mill, but this is really long. This is 250-260mm long end to end, and my mill just doesn't have the head capacity to get this in underneath. It would have been a real squeeze. Whereas the lathe, I can fit this in and use the reamer and guarantee both bores will be the same size based on that reamer, whatever that size happens to be. I've never used this reamer yet. I think it might cut slightly oversized. I've checked with Martin, he's going to make the pistons to suit once he's got the cylinder block, so that's not an issue. So yeah, we're going to use this in the lathe, and what it also allows me to do is, because of these checks that I'm doing at the moment on squareness with the clock, because I know my block is all square, I can then drill this hole out, or both holes out, through the block. I can then drop a boring bar in to make sure that the bores are absolutely square to this front face with a boring bar before I put the reamer down, because the reamer will just follow whatever's previously there. So that will ensure good squareness to the front face, well, all the faces actually, but mainly the front face and the back face. So that's where we are. Not an ideal setup, I grant you, but it's a way of me getting around this. A bit more fiddly to set it up, granted, and my biggest Achilles heel is going to be I'm not going to be able to run the lathe very fast at all to do this operation, which is fine for the reaming, but for the drilling out and boring I'm going to have to just really take my time, because this part is quite one-sided. I'm going to have a lot of the lathe jumping around if I try and run this much faster than a couple of 100 revs a minute, but I'm sure that'll be fine and we'll work around it. So that's my current circumstances. I've roughly set up on this hole, as you can see. I've just used the DTI. While it's in the lathe, you can see it's not perfect, it's just somewhere near. So what we're going to do now is get a centre in the tailstock and another centre in between it, and we're just going to hone in on our zero. Okay, bit of iteration between concentricity and squareness, but we're about where we need to be now. So this is a 5/10 per division clock, and when I'm checking the concentricity we've got just under 1 division of movement, so we're probably 3 or 4/10 of a thou clocked in on that. And then I'll just readjust this for squareness. So we're about on zero there, and the tripod's in the way. I'll just move the tripod. There we go, hopefully you can still see that. So what I can do now is scan this face. In fact, I need some more cross slide. Let's do that again. So we're about on zero there, and then as I come towards me I can dodge the holes in the face. And pretty much bang on all the way across that face wherever I move it to. Happy with that. So I'm going to get set up now with the drills. Now, one thing that's going to be interesting, you can just see one in view there. There's the steam port holes here that go through into the bore at both ends of the block. Obviously that's going to mean some intermittent cutting with the drills and the boring bar and the reamer at some point, but I've done it that way around deliberately so that I don't have to try and deburr. If I did it the other way and put these holes in afterwards, I'd be trying to deburr a hole inside the cylinder bore, which is invariably going to lead to me scratching up the surface of the cylinder bore. So I'm just going to need to be careful as we're drilling into this and reaming in that we're not grabbing on those through holes. Okay, so what news? Well, the news is I'm having an absolute nightmare with this. So that 20mm reamer, the original idea was ream it and then use something like a cylinder hone to surface improve, based on Martin saying he's going to make the pistons to size. Therefore, if I went, you know, slightly over the 20mm by a few tenths, it wouldn't matter. So that was the original intention and plan. What's actually happened is this thing, I think it's a combination of this and the fact that this stuff is just, I think, low grade mild steel, and it's just torn the inside of the bore horribly. So I've been faffing around trying to take light skims with the only real boring bar that I've got that will fit down here. You know, ideally for this, in this situation now, I need a really stout high-speed steel boring bar that will get down there that full length, which is, you know, 65mm length. I don't have, without grinding a massive chunk of high-speed steel from rectangle to round. That's my only option, and I'm not doing that because that's wasteful, and I'll be here forever doing it. I don't have any decent bar stock of the right size to do anything to make one in the workshop at the minute, and we're approaching kind of shit or bust with this job. So what I've done is I've taken a carbide insert for this boring bar, and I've used a diamond needle file, because again at the moment I don't have any green grit wheels that are set up that I can use for grinding, and I've basically put a positive rake onto the insert, a really fine point with a very tiny radius both filed and stoned onto it, and we're going to give that a try down the board to see if we can take out some of these imperfections. You know, they're not massively deep, they're only probably a couple of thou deep or something, but that's where I'm at the minute. To turn anything down, I could still do it. I'd need to knock the whole 4-jaw chuck off with the part in it, put the 3-jaw chuck on. I've got some 40mm bar that's long enough to do what I need to do, but I need to be turning it down to, I don't know, 16 or something like that, which just doesn't feel right. So we're going to give this a try. If this doesn't work, I'm going to be drawing stumps and going to order some bar stock that I can use to make a high-speed steel type boring bar out of, using an old slot drill or something poked through the end of it, and we'll see whether that does the trick. But I really need a sharp point down here, and I'm also limited on speed, so carbide's not the right thing for this, because I can't go any faster than sort of 350 RPM without the lathe wanting to shake itself apart. So these are the sort of challenges that you come up against. So we'll give this idea a bit of a whirl and see what happens, and I'll keep you posted. Okay, we're still persevering, I think we'll use that word, with this first bore. So we've got it to a point now where we've got a decent surface finish most of the way through. There's a couple of little bits that are still to go, and it's beyond me doing anything with a turning tool with it, so we've opted for some polishing techniques. Now, the bore hone, cylinder hone tool that I showed you earlier on, this piece of junk, which is a Sealy product, yes, it was as cheap as chips, and rightly so. Utterly useless, complete waste of money. So if anybody's going for one of those, don't bother. This has fallen apart more times than I care to remember. Completely useless. So what we're doing now is we have made possibly one of the simplest tools ever, and using it to good effect. So I'll just show you that. So this is nothing more than a piece of 10mm bar with a slot cut in it, and it's lined up square with the bore, and basically just with a bit of emery cloth you slide it into the slot, wrap it round in the direction that the chuck's actually moving, and then we're feeding this in and out using power traverse in and out of the bore. What that does do is maintains the fact that the bore stays round. I know the bore's round because I've bored it, pre-bored it with a boring bar and a reamer as it goes. The difficulty you've got is you stand the risk now putting a taper into the bore if you're not even with the amount of polishing that you do at either one end of the bore or the other. So that's why I'm using the power feed to feed in and out to try and keep the amount of work that emery cloth does in the bore uniform. But a very, very useful tool. You know, it's the most simple thing, and when you've got to the point that you'll see where I've been going through, you can see where the bits of emery cloth are worn, where it's been in contact, and you think, well, I'm losing all that bit in the middle. Well, actually no, you're not. You just rip the tiny bit off that you've used, and then switch it around the other way, put it back in, and that will present you with a fresh piece of emery cloth to go back down with. So very economical in terms of use. So I'll just show you a little bit of that, and I will persevere until we've got this bore where it needs to be. I've checked with Martin, and Martin's quite happy that I'm good to go slightly oversized on these bores, so he's still got the pistons to make to fit. So I think we've got a method, albeit not an ideal method. So I'll just show you a bit of that. So a handheld here, guys, best I could see, that's pretty good down there now, and I'm still measuring parallel with the bore mic all the way down the bore. So we have our method. We will set back up for the second cylinder bore. I'm not going to film that because it's the same as this one, so I'll bring you back when we've got to the end of it. Well, there we go, that's got our cylinder block finished, so happy with that. Got our bores, which actually just like glass. I wish it was Feely Vision, but that's a whole different part of the internet. So yeah, happy with that. That's been an interesting part to make. Some challenges along the way through poor tooling selection, material behaviours, that kind of thing, with this being mild steel. But that's all finished and ready to go back off now to Martin. Again, I don't know if I've tried showing the bores before. It's difficult in here to get the light, but they really come out nice. And what I've got, just using my bore gauge, telescopic bore gauge, I have got the same feeling top and bottom of both bores and all the way through as best I can using a telescopic gauge. So they're oversized, as I said earlier, but they are a matched pair, so that should make it easier for Martin when he's making the pistons. So with all that being said and done, I will join you at the board and we'll just wrap this episode up. Well, there we go, guys, that gets us to the end of the marine engine twin cylinder block for Martin. So I'll be getting that posted off to you very shortly, Martin, when I finally make a trip to the post office, and I'm going to try and get a few other bits of mail calls done that have been overhanging me for about a year, probably with stickers and various other bits and pieces. So we'll do a job run to the post office shortly, so I'll get that off to you, Martin. I hope that's got you what you want, I hope it all fits and works together with the bits that you're making. Hope the viewers have enjoyed that. You know, it's been nice making something to print for somebody else. That's not what I normally do. I make things to rough old sketches at best at the moment in here for myself, so it's nice working to somebody else's design. And I hope you found some of the ways I've gone about that interesting, including the workshop tips video that you'll have seen preceding this one around squaring the stock up in the first place. And again, you know, the root of any good job is making sure that you start your foundations. It's like building a house. If your foundations are shaky, the house will not be good. So that squaring up of the stock and getting everything right to start with on a job like this is absolutely fundamental for getting good positional accuracy and good accuracy across the remainder of the job as you start putting other features into it. So I hope you've all found that interesting, and thank you to the subscribers and the new subscribers that have come along, and we'll catch you all very soon on another video when we'll be making something else.